Good morning, class. Today we want to look at a new topic in our syllabus series, and this topic is algebraic expressions. Now we want to let's first of all know what is an algebra. Now algebra involves the use of pronumerals, which are basically letters that represent numbers. When we talk about pronumerals, these are letters, alphabetical letters. They can be English alphabetical letters. They can be any other alphabetical letters in a given language. And when we use such letters to represent mathematical numerals, we call that one algebra. For example, we can say let the letter number A equals to the letter A equals to a number 5. So in such a situation, this is called algebra, because we have used A to represent a number 5. We can also say, let's say a number T equals to 10. So if T is a letter and it represents a numerical number 10, then this is algebra. We can also say let a number D represent 20. So if this is a correct mathematical expression, then this is called algebra. So in that case, now you can see that these pronumerals are basically alphabetical letters ranging from A up to Z. But you can see that in this particular arrangement, we have excluded the letter O. Why do we exclude the letter O? Because the letter O is similar to a number 0. That's why it is excluded from our pronumerals. So whenever we use any letter to represent a numerical number, then that is called algebra. So algebra are therefore used in a situation where we want to hide the numerical value of a given quantity or measurement, or in any situation we want to hide it, and therefore if we hide it, we are now looking for a way of finding the numerical value from the hidden statement. An example, we can say that in a given school, year 10 class has the number and in a given school, year 10 class has D number of boys and G number of girls. D number of boys and G number of girls. Then we ask the question, what is the total number of students in that class? So here we have D number of boys and we have G number of girls. Because the number of students is defined by that particular statement, in that class, it will be you add the number of boys to the number of girls, and that will be the total number of students in that class. So total number of students therefore is given by total number of students is given by, so students, the total number of students in year 10 will be given by number of boys, which is represented by D, plus number of girls, which is represented by G. And this one now is known as algebraic expression because we don't know the number of boys in this class, numerical value. We are just being told that the number of boys is D, and similarly we don't also know the numerical value of the number of girls in the class. We are only told it is G. So to get the total number of students in this class, we basically add the letter D plus letter G, and that gives us the total number of students in that class, of which we have not been given the numerical value. Because this D can be any number. D is any numerical value. D can even be 10. It can even be 15. It can even be 20. It can even be 1,000. So because we don't know it, we just say total number is D plus G. Now let's look at another example. We have been told that James is twice as old as Irene. These are two people. We are comparing the ages of two people. We have been told that James is twice as old as Irene. That is the statement we know. So from this statement, we want to give what we call a mathematical meaning out of it. We want to derive a mathematical meaning from it. So to derive a mathematical meaning from it, we can decide to say, let James be this years old, and we represent it with a pronumeral, which is basically an alphabetical letter, as we have seen. And this person is twice as old as Irene. So with that particular kind of information, we can derive what we call an algebraic mathematical statement, which will relate the ages of the two. Find the sum of their ages. And we have been told that we take Irene's age to be X. So if Irene's age is X and James is twice means, just from the mathematical numerical value, twice means you multiply by 2. You take Irene's age and you multiply by 2. So we say 1 2 multiply by X. This will be James' age. Why? It is because we have James' age being twice that one of Irene. And already we have been given that Irene's age is x. So when we do that, we write this one as any number multiplied by a pronumeral like this. You just say it will be 2x. That is James' age. So Irene is x, James is 2x. And this is the mathematical statement that tells us that James is twice as old as Irene. So when he is twice as old as Irene, but Irene's age is x, then James' age is 2x. Once now we define the ages of the two persons, we can now just come and find the sum. And the sum here just means numerically addition. We add the two ages to get the sum of their ages. Are we together? So let's see. 2 sum of their ages. Sum of their ages is now 2x plus x. Why is it 2x plus x? The first part represents James' age. The second part represents Irene's age. So in this case, we can see that their age is now, the sum of their age is 2x plus x, where the first part is James' age. The second part is Irene's age. But you can now see that we are using the same unknown, which is our pronumeral. There is x here and there is x there. When we are using the same pronumeral and we are adding or subtracting, then we add the two. Here we assume that for x, we can rewrite this one as 1x. For x, we can write that one as 1x. So here we are adding 2x plus x. And if we are adding 2x plus x, this is how we can do the addition. We have 2x plus x, 1x. So because x is here and x is there, we are allowed to filter it because it is common and write this one as x into, we open the bracket because it is here and it is there, x into 2, these two here. I will explain what these two means and this one means in our next example, plus 1. Why are we doing that, class? It's because there was x here and there is x here. So we can filter it out, put it out of a bracket, and then use the law of BODMAS to simplify this particular expression. In bracket, you can see this is now 2 plus 1. And 2 plus 1 numerically is basically 3. So once we have that, we come and now write 3 multiplied by x. I am interchanging the position of x, and I'll explain why sometimes we do interchange, because 1 Remember in year 8 we say that multiplication can be commutative. Multiplication is commutative. Multiplication is commutative, and commutativity of a multiplication means this. If I have 2 times 3 and I interchange the position of the numerals to 3 times 2, it will still be the same answer because that will still give us 6. If I have 5 times 2, which is 10, is the same as still writing 2 times 5, which still give us 10. If I have 7 times 1, which is 7, this is still the same as writing 1 times 7, which we still get as 7. So you can see that if we interchange the position of the multipliers, we still get the same answer. And that is now what explains commutativity of multiplication. That I can interchange the position of a multiplier but still get the same result. And that's why I'm at will, when I write x here and again come and write it here, I'll still get the same results. So here we have 2 plus 1, which is 3. Then we multiply by x, and this one just gives us simply 3x. So the answer here will be 3x. That is what we do to get the sum of the ages of the two persons. So when the pronumeral is the same, we add so that we simplify. But if they are different, where in a case where we are using d plus g, it just remains as d plus g. So we don't go ahead to simplify, but here we do what we call further simplification, because the pronumeral we have used is 1. It is x and it remains x in both cases. That's why we have gone ahead to add the 2 to get 3x. And the procedure of getting 3x, I've said, once it is common everywhere, you filter it out, then you add the numerals that are attached to the pronumeral. Now we want to move ahead and now define this pronumeral and this the number 2 and the number 3. What are they in algebra? So we want to define their meaning so that they have their mathematical definition in algebra that we are going to use from today onwards. Now, in this particular case, we have 2x. We have 2 multiplied by x. There is that 2. This is where we started from. We say, first of all, said 2 into multiply. The bracket means multiplication. So we have this as a pronumeral and this one as a numeral, mathematical numeral. So when a mathematical numeral is attached to a pronumeral, which is unknown here, they have their mathematical definitions. So these 2 here, which is a multiplier of that pronumeral, is known as a coefficient. Coefficient. It is known as a coefficient. That is the mathematical definition of that too, when it is attached to a pronumeral like this. Then this pronumeral here also has a special name in algebra. While this is a coefficient, this pronumeral here is known as a variable. So the number multiplier is known as a coefficient, but the pronumeral that we are using is known as a variable. I am going to explain what this one means. Why is it called a variable? Why is a pronumeral called a variable in algebra? Why is a pronumeral called a variable in algebra? So a variable. This is a mathematical unknown. It's just basically a mathematical unknown that are represented using letters. Now, when it is called a variable, the value keeps on changing. It can be anything. That is why we call it a variable. So a variable is a mathematical unknown. It's a mathematical unknown in an algebraic expression. It's a mathematical unknown in an algebraic expression. Now, the word variable here means that the value of the pronumeral we are using can be anything. For example, if I say, like in the case 1, look at example 1. We say that we have D number of boys and G number of girls. So in this case, we have D number of boys which we don't know the specific numerical value. And we have G number of girls which we don't know the specific numerical value. It can be anything. And we have said the D can be, it can even be 0. We can have no boys in that class. That is the starting point. We can be talking of a class that we have this number of boys, but when we go to that class, we find there are no boys. So D is 0. That D can be 1. That D can be 2. Can have 2 number of boys. That D can be 10. We can have 10 number of boys. That D can be 100. We can have 100 number of boys in that class. That D can be 1,000. It can also be even 1 million because we don't know the exact number. So it can be anything and so on. So this D, it can be any numerical value, and that's why it is called a variable, because the value keeps on. It can be anything. You don't know the specific numerical value, and that's why it is called a variable, until we have a situation where we are guided by a particular algebraic equation that can now be able to solve the exact numerical value of D. We cannot ascertain that D is basically, let's say, 10. And that's why now it is called a variable. Similarly, G can be anything. G can be any number. It can be 0. It can be 20. It can be 80. It can be 200. It can be anything. 300 and so on. That's why they are called variables, because we have not defined the specific value of D. We have not defined the specific value of G. So it can represent any numerical value that is mathematically correct. And that is why we call it a variable. So a variable is an algebraic pronumeral whose value is not specific. We don't know that value, it can be anything. But once it becomes specific, now it becomes a solution. We have resolved. So we know that D can be 10. That is now a solution. G is 80. That is now a solution. But before we know the value of D, we know the value of G. Those are just what? Variables. So in this case, this particular pronumeral x is a variable. This 2 here is a coefficient. So what is a coefficient? A coefficient is just basically a number multiplier of a variable, a numerical multiplier of a variable. That is called a coefficient. So coefficient is a numerical multiplier of a variable is known as a coefficient. So later on, when we shall be looking at further problems in algebra, we'll be dealing with coefficients and variables. So from today, we shall be referring to such a kind of expression as a coefficient for 2 and a variable for x. So when you talk about variables, these are just but pronumerals that represent algebraic expressions in a mathematical statement. And when we have it as 3x, then 3 becomes a coefficient of x, where x is a variable. Are we together? I hope that is clear. And from today, when I now refer to a variable and a coefficient, you basically know what I mean, or what we mean. So class, let's now look at examples of the same problem. So class, we want to look at examples on variables and coefficients. And this particular exercise, we just want to state, we have been given an algebraic expression. The first one is 4a. Now in this one, we want to state what is the coefficient and what is the variable. So from the definition we have given, what will be the coefficient here and what will be the variable here? So you can appreciate, yes, good, that for this case, 4 is a coefficient, so we write 4 as our coefficient. And our variable, because it's an alphabetical letter that represents, is a pronumeral that is used to present alphabetical numbers, letters, it becomes a variable. So our variable there is A. So coefficient is 4, variable is A. How about here? Yes, coefficient is a half, and our variable is M. Likewise here, what is our coefficient? It is 6. How about the variable? Is P. Here, coefficient is 3. Good. And our variable is R. Very good. We are proceeding on well. So you can now see the definition of variables and coefficients. How about 7Q? What is the coefficient? Yes, 7. Variable Q. Here, what is our coefficient for 5 over 9D? What is our coefficient? Yes, 5 over 9 is our coefficient. How about our variable? Our variable is D. So you can see we have successfully identified coefficients and variables in algebraic expressions. And from this particular statement, now we are ready now to do further examples and even do simplifications when it comes to algebra. So let's look at more examples that will now lead us to algebraic expressions of advanced nature. So for example, class, we can be given the following. So class, this is an example that now brings us to understanding what we have discussed this morning in terms of coefficients and variables. Here we have been told that 3 people, Ben, Alea, and Victoria, are visiting the arts gallery. The 3 of them combined have $C. the amount of money they have is C dollars. So this C represents any amount. We don't know exactly how much they have, but we have just been told that they have C dollars between them. Drinks cost D dollars. When they buy drinks, the total cost of the drinks will be D dollars. And Ben has bought X postcards in the gift shop. So you can see those are now mathematical algebraic statements that we want to derive a mathematical meaning from. So we have been asked, write expressions for the following. The first one is the cost of 2 drinks. A drink costs D dollars. So the cost of 2 drinks will be, let's assume that 1 drink costs D dollars. So if there are 2, we basically just multiply by 2. So 1 drink is equal to D dollars. But now there are 2. There are 2. So it means if there are 2 drinks, we multiply the cost of 1 drink by 2, where 2 now becomes our coefficient. Remember, we have said that our coefficient is just a number multiplier of a variable. D is a variable because we don't know exactly how much that drink is costing. So the cost of 2 drinks will be $2. That is how we write it, $2, because it is $1 multiplied by 2. So we get $2. Then part 2. Part 2 of the equation says the amount of money each person has if the money is shared equally. Remember, we were told that the combined amount of money they have is C. But this is a total contribution of the 3. They are 3 and they have agreed that let us contribute so that the total amount of money that will help us visit the gallery successfully be C. So each person here is mandated to give an equal share of what they require at the gallery. And what they require at the gallery is C. So therefore it means that if it is C, let's assume that this C is equal to $90. That is an example, $90. That C is $90. They require $90. So if they require $90, it means therefore that each person, because they are 3, each person will be required to contribute each person will contribute $90 divided by 3. So this $90 divided by 3, $90 divided by 3, each person will require $90 divide by 3. And the highest common factor between 90 and 3 is 3. So 3 divides 3 once, and 3 divides 90, 30. So each person will contribute $30. That is an example where we know the specific value of C. But because we don't know the specific value of C, it will just be C dollars divided by 3. That is the amount of money each particular individual is supposed to contribute for the purpose of this particular visit, because we have been told that the total money they require for that visit is C. And therefore, because they are 3 and they are contributing equal share, it will be C divided by 3. So there we now write C dollars divided by 3. And you will appreciate that a division can be written in 2 ways. We can write it as, if we have C divided by 3, this can also be written as C multiplied by 1 over 3. And C multiplied by 1 over 3 can also be just written as C over 3. So this one I can write it as or just like that. So C dollars divided by 3 will be the equal amount of money each person will contribute, which we have continued to simplify in that particular respect. Let's move on to the next question on that. So class, you can see that statement number 3 is now what we call a compound statement from the original statement we were given. We were told that Ben has bought X postcards in the gift shop. But now here the question is asking the number of postcards Alea and Victoria bought. If Alea bought 3 more than Ben. So we start from there. Remember, Ben bought X. So if Ben bought X and Alea bought 3 more than Ben, it means that in addition to what Ben bought, which is X, Alea exceeded by 3. So if Ben had, so for Ben, we start with Ben. Ben bought X. That is Ben. Therefore, if Ben bought X, Alea will buy X plus 3. Ben started by X. Alea bought X plus 3. So here we write Ben bought X postcards. That's statement number 1. Alea bought X plus 3 postcards. So you can see Alea bought 3 more. What Ben bought, Alea added 3. That is up to this statement here. More than Ben. 3 more than Ben. That is for Alea. We come to this part. Victoria bought 5 less than twice. This is now even a more complex statement that we must synthesize and write it as interpret it as a mathematical statement. Victoria bought 5 less than twice the number Ben bought. 5 less than twice. So here, what it means, we get what Ben bought first. We get what Ben bought first. And when we get what Ben bought first, we get twice of what Ben bought. Twice of what Ben bought equals to 2x. Twice of what Ben bought is 2x. Are we together, class? Because originally Ben bought x, but twice that will be 2x. So we want to get an expression of what Victoria is buying. Because Victoria, we've been told, Victoria bought 5 less than twice. 5 less than twice. Less means just below. So 5 less than twice means you get twice what Ben bought, then you subtract 5 from it. So Victoria bought this is the statement. Victoria bought 5 less than twice the number Ben bought. Originally Ben bought X, but now twice what he bought, we multiply by 2 so that our coefficient is 2. Then twice, 5 less than twice, it means you get 2x minus 5 to get the total number of what Victoria bought. So Victoria bought 2x minus 5 postcards. But look at this statement, class. The number of postcards Alea and Victoria bought. What do we do here? Do we add or we just leave it the way it is? It is Alea and Victoria. Now, we have simplified what Alea bought, which is x plus 3 postcards. And we have also simplified what Victoria bought, which is 2x minus 5 postcards. But here, you are right to leave this particular statement the way it is, because here we have said Alea bought x plus 3 postcards and Victoria bought 2x minus 5 postcards. So you leave it like that. The situation will be different if we were asked the sum of postcards Alea and Victoria bought. But because there is no sum, we leave it just as simple as that. That is how we simplify the statement. So class, let's look at examples on what we have been discussing this morning. The first one is the cost of 5 pencils at X cents each. 1 pencil cost X cents. 1 pencil cost X cents. One pencil cost X cents. So if they are 5 and one cost X, this one will just be 5x cents. You multiply the cost of 1 pencil by 5, you get 5x cents, where 5 here is the variable, the coefficient, and x is our variable. Now, the cost of Y apples at 35 cents each. This one you also just multiply. 1 apple cost Y 35. An apple costs 35 cents, but they are Y. We don't know the number. So just get what the cost of 1 apple multiplied by the number. That will be the total cost of buying the Y apples. So cost of Y apples will be 35 Y cents. You multiply 35 by Y, you get the total cost of Y apples. Part C of our question, one person's share if 500 is divided among n people. We have $500 and we have n people. We want to divide this 500 between n number of people. So we say is given by the amount they are given to divide by the number of people we have. So for example, this n can be 100 people, and we have $500. So it will be one share equals to $500 divided by 100. And since the highest common factor between 500 and 100 is 100, when you divide 500 by 100, one share will be $5. So each person will get $5 if they are 100. Suppose n is equal to 50 people, and we have 500 to divide between 50 people. That will be one share equals to $500 divided by 50 persons. But since the highest common factor between 50 and 500 is 50 itself, when we divide 500 by 50, we get one share being equal to 500 divided by 50 is basically $10. So each person will get $10. That will be the share per person. Assume that n is equal to 200, not 200, but let's say 10. N is 10. So one share will be equal to $500 divided by 10. And since the highest common factor between 500 and 10 is 10 itself, we get one share being equal to $50. So that is the mathematical connotation that we get when we are being told that n number of people and they are to share $500. So n number of people will share, therefore, in general, one person share will be $500 divided by n. So once you have that, n can be any number, because remember, these are algebraic expressions. N can be any number, as already we have defined examples of n here. We started with n as 100, n as 50, n as 10. And that is how we get a person's share if that is the case. So we leave it like that. Number 4, the cost of pizza is $11. And it is shared between m people. The same statement as statement number 3. So this pizza cost $11 is divided by m people. Let's assume a situation where m is equal to 11. M is equal to 11. When m is equal to 11, we get one person contributes $11 divided by 11, because m is 11. So $11 divided by 11, the highest common factor between 11 and 11, it's 11 itself. And therefore 11 divided by 11, you get 1. So each person contributes $1. If there are 11 persons assume that m is 1. We assume that, so the first case m is equal to 11, and we get 1 contribution equals to $11 divided by 11, and that gives you $1. A situation where m is 1, m is 11. Suppose m is equal to just one person. One person wants to buy the whole of that pizza. It will now be contribution equals to $11 divided by 1, and that gives you $11, because the highest common factor between 1 and 11 is 1. So 11 divided by 1 is 11. Suppose m is equal to 10. So contribution equals to $11 divided by 10. And when you divide 11 by 10, you get $1.1. And $1.1 is $1.10, because 100 cents, we shall see how we can convert $1.1 later on into $1.00. So here we get, for part C, that is that, part B, contribution of each person equals to divided by m. That is the contribution of one person towards the purchase of this particular pizza. And therefore, that one, because you have given various numerical examples where the value of m keeps on changing. Remember, m is a variable, so we can take any numerical value of m to get the cost of each person towards the purchase of that one pizza. Finally, Paul's age in X years time, if he is 11 years old now. Now he is 11 years, but in the next X years, these X years can even be, X can be 1, or it can even be 0. X can be 1, X can be 2, X can be 3, X can be 4, and so on. So this X can be any number. So in the next X years, we take his age, present age, and we add to the X years that are coming. So when X is 0, his new age will be 11 plus 0, which is just basically 11. That is a situation where X is 0. A situation where X is 1, his new age will be 11 plus 1, which will be 12 years. A situation where X is 2, it should be 11 plus 2, which is 13 years. A situation where X is 3, it will be 11 plus 3, which is 14 years. A situation where X is 4, it will be 11 plus 4, which is 15 years. So you can see X can be any number. So his age in the next X years will now be in the next X years class, Paul's age will be X plus 11, and we have said that this particular x can be any number, and therefore we add to his present age to get his next age. Class, that marks the end of our lesson today. Next time we meet on advanced algebraic expressions. I hope you have enjoyed the lesson this morning. Have a good morning and enjoy your day. Thank you so much.